So today what we're going to do is we're going to build off of our last lesson when we were solving simple inequalities, and now we're going to talk about multi-step inequalities. We're still working on those same two skills. We're creating equations and inequalities in one variable and using them to solve problems, and then we're solving equations or inequalities in one variable, including equations with coefficients represented by letters. So to do that today, there's no new vocabulary terms, but we want to keep thinking about that idea yesterday, is that we follow our equation solving skills when we have addition or subtraction of positive and negative numbers. We follow equation solving steps when we're doing multiplication and division of positive numbers, but we have that idea of with a negative number, we have to flip the direction of the inequality symbol. So today what we're going to do is we're going to think about the idea of 1 is less than 3. You should agree with me on this one. 1 is less than 3. If I have my alligator mouth, I want to eat 3 cookies instead of 1 cookie. But if I think about this, if I add 1 to both sides, so if I add 1 to both sides, I get 2 is less than 4. Well, that's still true. I agree. If I take away from both sides, I take away 1 from both sides, I get 0 is less than 2. Again, still works. I can follow those equation solving skills for addition and subtraction. If I think about multiplication and division now, well, we'll multiply by a positive 2. If I multiply both sides by a positive 2, I get 2 is less than 6. I still agree. But if I multiply by a negative number, so if I multiply both sides by a negative 2, I get a negative 2 and a negative 6. My original symbol here shows me that negative 6 is greater than negative 2. And that's not true. If I'm thinking about my number line here, I have 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Well, negative 6 is sitting right here, and negative 2 is here. The absolute value is greater, but the actual value here, negative 6, is less than negative 2. So my symbol is the opposite direction. Same thing for division. If I were to divide, so now that I have a new true statement that negative 2 is greater than negative 6, if I divide both sides by, let's divide by a negative 1. If I divide both sides by a negative 1, I get 2 and 6. Well, again, this time, if I want to have a true statement, I need to flip my symbol. So it's when we multiply or divide by negative numbers that the direction changes. Tricky. Might be easier at this point in your mathematical career to just memorize it, that it flips the sign if we multiply or divide by a negative number. So for our practice problems today, I have a bunch of questions out of the homework. So if you're following along with this video, you'll have a good start on your homework. The first one is from page 300, number 3, and I want to solve and graph. So to solve it, I'm going to follow my equation solving skills to isolate the variable. First step is to add 10 to both sides, and I get 6h. Addition and subtraction, my symbol does not change direction. Oops, 42, not 6. To get h by itself, I divide both sides by 6. Well, again, using my rules, it's a positive number that I'm multiplying or dividing by, so I don't change my sign. So I get h is greater than or equal to 7. Build a number line, center it on 7. Because I see that I have that or equals to piece, I have a closed circle at 7, and I want to point that h is greater than or equal to. So if I plug in a sample value to check, I get 8 greater than 7. Yes, so that's the side that gets shaded. If I do this next one here, again, homework problem, page 30, number 30 this time, I'm going to follow my equation solving skills. So if I look at this, the first thing I need to do is I need to get rid of those parentheses. So just like with my equations, I can use my distributive property to simplify inequalities. And I get 21 is greater than or equal to 3 times a minus 3 times 7 plus 9. Well, I get 21 is greater than or equal to 3a. I have a minus 21 and a positive 9. So I get a minus 12. Next step is to add 12 to both sides. And I get 33 is greater than or equal to 3a. Well, again, now to get my a by itself, I'm dividing, but I'm dividing by a positive number, so my symbol stays the same, and I get 11 is greater than or equal to A. Create my number line, centered at 11. And in this case here, I have a closed circle. I see that I have that or equals to piece. And I want 11 to be greater, so I want all values smaller than 11. And I can do that with a little quick check. If I plug in 10, I get 11 greater than or equal to 10. Yes, that's true. I shade the side that's true. Continuing on with some more homework problems. We're just increasing the complexity, but it's still the same skills we've been working on. First thing I need to do is I need to simplify each side of my equation. Well, on that first one, there's nothing I can do to simplify it. I'll just copy down my problem. But on the other side of my inequality symbol, I can distribute. I get 2 times 3 is 6, plus 2 times y is 2y. Well, now, I want to get my y's on the same side of the equal sign. Well, to do that, I've got to get rid of 2y. At this point, alarm bells should be going off in your brain. My y's cancel out, and I'm left with the statement 4 is greater than 6. Is that true? No. No, it's not. Is there anything I can do to have 4 equal 6? No. So this one is what's known as a null set. So a 0 with a slash through it tells me that there are no possible values that make this inequality true. There's nothing I can do to have this side of the equation be greater than this side of the inequality, not equation. So this is a null set. Null set. And I can represent that with the symbol null set. So, if possible, I would graph the solution, but in this case, there are no possible solutions. There's no solution or a null set as the solution. Tricky, tricky. Number 32, I'm going to start with the same sort of process. I'm going to distribute to get rid of my parentheses, and I get 6 minus 3b is less than 10. Well, I've got to distribute again. This is really that negative 3, so I get plus a negative 3b, and then minus a negative plus 18 here when I multiply. Now I want to get my b's on the same side, so I'm going to add 3b to both. Oh, I should probably simplify first. I'll simplify my right-hand side of the equation, or inequality first, and I get a 10 and an 18, so I have 6 minus 3b. 10 and 18 give me 28 minus 3b, or plus a negative 3b. When I add 3b to both sides, again, alarm bells should be going off because it cancels out. But I'm left this time with the statement 6 is less than 28. Well, is that true? In this case, yes. So how many solutions, or what solution set do I have here? In this case, all values are true. To show that, I can write that b, my variable here, b, oops, let's change colors so we have our answer in red like on the other one. I'm going to use that idea of the set builder notation that I talked about. I'm going to do the wiggly thing. B is all real numbers. Real numbers. So my solution set includes all real numbers. Anything that I do to this is going to wind up with a true statement every time I get 6 is less than 28. So, just like with our equations, we can have one solution or one type of solution. I can have no solutions, that null set idea, or I can have infinitely many. So if I wind up with a true statement at the end, I know that my variable could be any real number. Last practice problem for today. I'm going to define the variable, write the inequality, and solve and graph the solution. Well, in this case, I have a number, so I want to call, let's say that a number, let's use k as our variable today. 8 times a number minus 27 is no more than the negative of that number plus 18. So I've got to write an inequality here. 8 times a number, well, that tells me 8 times a number, that's 8k, minus 27 is no more than, so this is going to be my symbol in between. I'm going to hold on to that for a second. And we're going to write the second half here. The negative of that number, So the negative of that number plus 18. Negative of that number plus 18 is negative k plus 18. But now I want to think about the symbol. No more than. I want this side, my green side, to be no more than. Could be equal to. The no more than tells me it could be equal to. But no more than. Is 7 no more than 8? Yes. My symbol is going to face this direction. Well, now I need to solve it and graph my solution. To solve it, first thing I need to do is I need to add to both sides 27, and I get 8k negative k plus 45. Well, I'm going to move my k's over to the same side, and I get 9k is less than or equal to 45. Last step, I'm going to divide both sides by 9, and I get k. Oh, let's scooch. My head's in the way. We're going to scooch over this way. I get k is less than or equal to 5. When I graph my solution, I center it on 5. And I'm going to have a closed circle because I have that or equals to piece. And I want values that are less than 5. So, trickiest part here is to get that equation or the inequality written correctly, and then I can walk through the steps to solve for my answer. Homework tonight is page 300, numbers 3 through 30, multiples of 3, and then 31 and 32, which if you've been watching the video, we've solved already, and then 39 and 58. Good luck.